Parallelograms. All right, let's look at the properties of our parallelograms, and then we'll look at what that means for our examples when we're determining sides and angles of our parallelograms. All right, so opposite sides are parallel. So what does that mean? That means that this side right here, is my pen gonna work, is parallel to this side, meaning that they're never gonna meet. Oh, I didn't write parallel here, did I? Oops. And then that also means that this side is parallel to this side. Remember those little arrows on your lines mean parallel. All right. Opposite sides are also that pen's not going to work. Let's congruent, meaning that they're the same size, right? So what does that mean? That means that this side is the same length as this side. This side is the same length as this side. So if this top was 10, this bottom would be 10, right? That's what congruent means. All right. Opposite angles are congruent. So this angle here, opposite is going to be the same angle. That means that these are going to also be congruent. Congruent. Consecutive angles, meaning ones that are next to, that are on the same side, I guess, are going to be supplementary. And what does that mean? That means they add to 180 degrees. So this angle plus this angle add up to 180. That means this angle plus this angle is 180, this angle plus this angle, this angle plus this angle. Each of these add up to 180 degrees. And finally, our diagonals. So the lines from one corner to the other corner, other corner to other corner, they bisect each other. And what does bisect each other mean? It means that they hit right in the center of both of those lines. That means that whatever distance this is, that's the same distance here. And whatever distance this is. Okay? Let's see what this means for some examples. All right, we want to know what is the length of AD. Well, opposite sides are congruent, so let's look at the opposite side. We know that BC is 8, so then AD must be 8. What's DC? We look, that's 15. Easy peasy. All right. We want to know the measure of angle A. So what is this measure? We're given that angle D is 68, and we know that these two angles here are going to what? They're going to add up to 180. So in order to find A, I'm going to take 180 minus my 68, and that's going to give me 112 degrees. All right, what is angle B here? Well, opposite angles here are congruent, so D 68, that's opposite of B. B has to be 68. What's angle C? Opposite one was 112, 112 degrees. Okay, we're just going to be applying the same properties. All right, number 2. We want to solve for x and find the measure of b. We're given angles as equations, of course, and we can use these properties to figure it out. We're given A and C. So our two options with our angles is they're either going to be congruent if they are opposite of each other, or they're going to add up to 180 if they're kind of the ones that are on the same line. These are opposite each other, so they are going to equal each other. And when I do that math, x equals 13. In order to find b, I need to find one of these first. So if I plug in x of 13 plus 11, then this gives me that this angle equals 63 degrees. Angle B is what we're trying to find. And I know that these two angles add up to 180. So if I take 180 minus 63, that gives me 117 degrees. That's B. Okay. All right, number 3, we're looking at our sides and our diagonals. And so we know sides opposite of each other are congruent, and diagonals bisect each other in the middle. So whatever is on this side of the diagonal, that's the same as the other side. So we want to know what UT is. Opposite side is 27, so that is 27. What's ST? Opposite side is 18, so ST has to be 18. What is VS? We know that UV is 7, so VS has to be the exact same, so that is 7. We're going to know what VT is. Well, it tells us down here that this whole is 30. Remember, this cuts it right in the middle, so if I take 30 divided by 2, VT is going to be 15. All right, our angles in this one with the diagonals. We want to know what let me try to get a different pen. DEC is. We want to know what this is. And we know, we're told down here that FED, so this whole angle here, this one is 134. So remember, if the total is 134, and part of it is 71, and I want to know the other part, I'm going to take 134 minus 71. That's going to give me 63. So this little piece right here, 63 degrees. Okay. C, we want to know C, D, E. So we want to know this whole angle. So remember, the angles that are on the same line, they're going to add up to 180. So this total angle, so then we're going to take 134 and subtract it from 180 because this whole angle is 134. That means that's 134 plus whatever this is going to be 180. So that's 46 degrees. Okay. ECD. So this angle right here. And if we remember anything about parallel lines cut by a transversal, because remember opposite sides are parallel, this would be a transversal. We're inside the parallel lines, opposite sides of the transversal, that's alternate interior angles. So that has to be the same as that 71 degrees. Okay, and finally, we want to know, where is it? D, F, E. So this angle right here, and we know that this total angle has to be the same as this one, which we found as 46. So 46 is the total, subtract out that 21, that other piece is 25 degrees. All right, let me know if you have any questions on our parallelogram.